Let's use this following graph to factor the polynomial x cubed plus x squared minus 16x plus 20. So I put this in place of y1, and I got this picture here. And what I'd like to do is just identify a few things about this graph. Like, clearly the degree 3 matches up with the picture. It goes up on this side and down on this side. So I'm actually going to write that down. The degree is 3. But I want to somehow use the zeros and the multiplicity to take this thing in expanded form and write it in factored form. So let's list out the zeros of this graph. There's one here, and there's one here. This was at, it says -5, and this one appears to be at 2. If I look at this 0, I know the multiplicity has to be an odd number, and I'm thinking that the multiplicity in fact is 1 since it passes directly through the graph. Over here, I see that 2 is a 0, but it looks like the multiplicity on this factor is going to be a 2 because it stays on the same side of the graph. So let's jot that down, that the zeros are -5 and +2, but in terms of the corresponding multiplicity, it appears that the one at -5 should have a 1, and the one at 2 has a 2. Now this is good. If I add those two things together, it should take me to the degree of 3, which it does. So the rest is now just a matter of using these zeros to write down the corresponding factors and somehow incorporate the multiplicities. Okay, if x equals -5 is a 0, it has got to be that x plus 5 is a factor. So the reason for that is if you put -5 in place of x, it creates this 0 within the equation. And the second thing is the multiplicity of 1 would just go in the exponent. We don't have to write this, but I'll place it in here. Now the second piece is x minus 2. If 2 is a 0, x minus 2 has to be a factor because 2 minus 2 is equal to 0. But the only difference is I'm going to put this multiplicity within the exponent here of 2. And in fact, this is the factored form of the polynomial that we have up here. You know, clearly if you multiply this thing out, you would have an x to the power of 3 with a 1 in front of it. If you check out the number that would appear at the very end, this -2 squared is 4 times 5 would take me back to 20. You could even graph this thing and match it up with this picture, and they're going to be the same thing. But this is how you can use a graph to factor a polynomial. List out the degree, locate the zeros, use those to create your factors, and place in the corresponding multiplicity. So let's try this in one more example where we have a slightly more complicated polynomial. I want to factor this equation by using the graph. So again, I put this thing in place of y1, and I had to zoom out a lot for the y values, but this is the picture that I see of my graph. I'm going to list out the degree. Well, clearly the degree is equal to 4, and that matches up with my picture. An even degree would go up on both sides since the coefficient here is a 2. So the next thing I'm going to write out are the zeros. Okay, the zeros appear to be -6, -1, 0, and 3. And the multiplicity for each of these appears to be 1. I mean, if you look at it, it's crossing over the x-axis at each of those. So that's nice. The multiplicity for each of those should be an odd number, and in fact that odd number would be 1. Like, that has a multiplicity of 1, so does this, so does this, so does this. But that matches up with my degree. If I add those multiplicities, it would give me a degree of 4. Perfect. So now when it comes to factoring this thing, I know the zeros, so I can simply write down the factors. They would have to be x plus 6 to the first power, x plus 1 to the first power, x you could put to the first power, and then x minus 3 to the first power as well. In fact, you don't really have to write these first powers. You could simply just put, x plus 6, x plus 1, x, and x minus 3. So this is a good start for the equation. So if I'm going to factor this, it would have to resemble this thing here. But there's a problem. That problem is I see that there's this 2 here, whereas if I multiply all this stuff together, I'm going to have just a 1 in front of my x to the power of 4. So I have to fix this in some way. And here's how I'm going to do it. I'm going to put a in front of this whole equation. And I'm going to choose a point on my graph. And I see that there's a point right here, which is -2, -80. What this means is if you put -2 in place of x, the corresponding y value is -80. So if I go over to my equation, if I put -2 here, 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 and here, the result should be equal to 80. So let's list that out. I have a times -2 plus 6 times -2 plus 1 times -2 times -2 minus 3. That should equal -80. This will allow us to solve for a, which we can then put back into our equation. So let's do that. This is a times, okay, we get 4, -1, -2, and -5. That has to equal -80. I have 3 negative values on the left, so it's going to be negative some number times a. So that's going to be 4 and 5 is 20 and 2 is 40. So that's -40a, and this should be equal to -80. If I now divide both sides by -40, I get that a is equal to 2. This now gives me the final answer to this problem. The polynomial in factor form would be 2 times x plus 6 times x plus 1 times x times x minus 3. So for the most part, using the zeros in the multiplicity is good, but because there was a 2 here instead of a 1, I just went one step further by choosing a point on the graph and seeing what value could I put in front of this whole equation so it would take me to the factored form of this, and that value was 2.